adaptations or factors and agents of pollination. Then we looked at fertilization. So after fertilization, we know that the fruits and seeds are formed. So today our main emphasis will be on seeds and fruits. Seeds and fruits. We've all seen fruits before. We've all seen seeds before. We've all eaten fruits before. We've all eaten seeds before. So it's nothing new to us. But the main thing is how they look like, their structure. That is what we are going to make our emphasis will be on today. So I'll begin the slide by showing you where necessary for me to read out. I'll read out where it's necessary for me to explain. I'll explain. Okay. So as we rightfully explained, stated, as rightfully stated last week, what a seed is. Now, a seed is defined as a fertilized or matured ovule. It's defined as a fertilized or matured ovule. That is what that is what a seed is. A fertilized or matured ovule. Now, the seed is structured to have an outer layer formed from the two integuments that is around the embryo sac. If you could remember, when we were doing fertilization, I was explaining where the integuments were, how they look like on the embryo sac. I explained them. Now, for those new in the class, I'm sure you could ask for the previous notes and to be given to you so that you know what we are talking about. So around the embryo sac of every seed, there are two integuments. This integument is outer cap. It's a covering, a layer of covering. That is what we call integument. That is found around the embryo sac, and this is called the seed coat. So the integument together form what we call the seed coat. Now this seed coat has two layers, as I made mention. The outer layer is what we call the tester. The tester is the outer layer. Then the inner layer is the tegmen. So every seed has two layers. Not every seed. Some the two layers are fused together as one. So we have just tester. But most are having two layers. The outer layer is what we call a tester. Then the inner one is the tegmen. Now, within the seed coat is an embryo and a cotyledon. So these two structures are found inside the seed coat. It's like you buy a biscuit. Now, the wrapper around the biscuit is the seed coat. Then what is inside the wrapper? The biscuit itself. Over here is the embryo and the cotyledon. Now, the main function of this seed coat is to protect the embryo of the seed. One, and aid in germination by absorption of water and oxygen. So the main function of the seed coat is to protect the embryo of the seed. Two, it aids in germination by absorption of water and oxygen. Now, when you go and see somewhere, what is the function of the tester? It's the same thing because the tester is the seed coat. The tegmen is also the seed coat. So if you are asked that question, you should know that they are asking you for the function of the seed coat. Now, the embryo consists of 3 structures. The embryo of a seed consists of 3 structures. One, it consists of the plumule, also called the embryonic shoot, the radicle, also called embryonic root. Then 1 or 2 cotyledons, also referred to as embryonic leaves. So the embryo of a seed consists of these 3 things: the plumule, the radicle, and 1 or 2 cotyledons. Now, after fertilization has taken place, the plumule develops into the shoot system. I'm hoping, or I have a fair idea that you know what a shoot system is. What comes out, the stem and the branches form the shoot system. Then the radicle forms the root system. So what goes beneath the soil is what we call the root system. So after fertilization, the plumule develops into the shoot system, then the radicle into the root system. Now, the 1 or 2 cotyledons, they, as the name sounds, embryonic leaves. So they normally tend to form the leaves of a plant. So this is just to show you how, or the structure of the seed. So in summary, you can have the seed having a seed coat. Now this seed coat has an outer layer called the testa and an inner layer, the tegmen. Inside the seed coat is an embryo and the cotyledon. Embryo and cotyledon. So this embryo is made up of the 3 structures. That is the plumule, radicle, and the cotyledon itself. Now, after germination, as I made mention, the plumule develops into the shoot system. The plumule develops into the shoot system, the radicle into the root system, then the leaves, embryonic leaves into the leaves. ITIL S12. Let me attempt to someone and get back to you. Hello. ITIL S12, the one using ITIL. Can you hear me? It looks as if you are suffering with your okay. ITIL S12. Can you hear me?
Yes,
ITIL. Hello. I could hear you. I could hear you.
okay, sir, please, I can hear you.
Are you struggling with your audio system?
Yeah, I was, but it's okay now.
It's okay.
Yes, please.
I wanted to show you a way to put it off. It's not off. Now, the cotyledons are the seed leaves, as I made mention. I also said that the embryo consists of 1 or 2 cotyledons. Now, the moment a seed or a plant contains 1 cotyledon, just one, that seed is referred to as a monocot plant or a monocotyledonous plant. So as you can see, I have in monocot, meaning that it has 1 cotyledon, that is 1 seed leaf, just 1 cotyledon. And in dicot, or when the seed or the plant has two cotyledons, we refer to as dicot. So have that in mind. So either dicot or monocot or monocotyledonous plant, or dicot or dicotyledonous plant. So these two things, it's all acceptable. Now, the cotyledon here is the main structure that stores food in dicot plants, plants or seeds. The cotyledon here is the main food storage structure for dicot seeds. Then the main food storage in monocot seeds is the endosperm. So always remember, the main food storage, what stores the food in a seed, in a dicot seed, a seed that is having two cotyledon, is the cotyledon is the one that stores the food. And a seed that has only one cotyledon stores its food in the endosperm. Now I'm going to make some things that would look a bit strange. After I finish, I will show you a diagram showing you the structure of both the monocot and dicot seed so that you know what I'm talking about. Now, the lower part of the plumule, as I said, the plumule is the embryonic what? Shoot. So the plumule, the upper part of the plumule is called the hypocotyl. And the lower part, sorry, is called the hypocotyl. Then the upper part is referred to as the epicotyl. Now the plumule is protected by um, a sheath, a protective covering called the coleoptile or coleoptile. That is what protects or covers the plumule. Then the radicle is protected by a similar shell called the coleorhiza. The coleorhiza. Now, for every seed, it has a scar. Now, this scar is the point of attachment of the seed to the wall of the fruit. The seed has a scar. It looks like something small that attaches itself to the fruit itself. That is what we call a scar. Now, that scar is what we call the hilum. The scar is what we call the hilum. So a seed has just one scar, point of attachment from itself to the fruit, the walls of the fruit. Now, above the micropyle, that is the position of the hilum. So the micropyle is the pore located below the hilum. Now, the two structures that I are seeing, you have one on your left, you have a dicot seed, then on your right, you have a monocot seed. Now look at the difference. Now with the dicot, the cotyledon is what you see inside, very big. It's made up of two. There are two, one on one side and the other on the other side. The radicle is there. You have your plumule. You can see it on the dicot. I'm showing you on the dicot seed. You can see your plumule as if it's a leaf-like structure. Then you move to your monocot seed. You can see the plumule shell I'm talking about. So the plumule is here, radicle is there. So the coleorhiza is covering the radicle. Then the coleoptile is covering over the plumule. Then you have the large cotyledon, just one, inside the seed. You have your endosperm there. So the endosperm here forms the main food storage for the monocot seed. Example, maize. Example is a maize. So this shows you the structure of a seed. This is a common seed, showing you how it looks like. Now look at the monocot seed. That is the maize seed. Now you notice that you have your tegment. That is the inner integument. That is the inner seed coat. Then you have your tester around. That is the outer seed coat. Now the next image shows you the position of the hilum. So this is the hilum. Now this hilum, this what you see here is a bean seed. Beans. Let me use a bean seed one. So the hilum is the point of attachment of this bean to the main plant or the main fruit. Then look at the position of the micropyle. Around is only the tester, no tegment, because the tester and tegment are fused together as one. So it's referred to as tester. Then position of a radical. So this structure gives you how our seeds looks like. So this is a nice way to look at the seed. If you are asked to draw an endospermous seed, the moment the word endosperm comes in, you are drawing a monocot seed. So you draw the monocot seed, not the dicot. Endospermous means that the endosperm is supposed to be present. Okay. Now, inside the seed, our fruits are formed outside. So the seeds are inside the fruits. Okay, so we are going to look at fruits. We are done with what is inside the fruit. We are looking at the fruit itself. Now, the fruit also has a definition, like the seed. That is, it's defined as a matured or fertilized ovary or fertilized ovary. Defined as a matured or fertilized ovary. Now, this fertilized or matured ovary protects the seed. If it has one, it protects the seed or it contains the seed. So these two things, that is the function of the fruit. It contains and what? Protects the seed. Contains and protects the seed. Now, fruits are classified, but we don't have types. You can't say this type of fruit, but the fruits are classified based on certain specifications. Fruits are classified based on certain specifications. Now, one, fruits are classified based on the part of the flower where the seed is formed. They can be classified based on where the seeds are formed as one, true fruits and false fruits. So based on the part where the seeds are formed on the flower, we classify them under true and false fruit. Now with the true fruit, it's formed from the ovary of the flower only. So only the ovary. It's formed from only the ovary. Example, you have orange, tomato. There are a lot. We'll be looking at more under them. So this is just something small for you to know what we're talking about. Then with the false fruits, they are formed from the ovary and other floral parts. So differences between the true fruit and false fruit. The true fruit is formed from the ovary of the flower only. Then the false fruit is formed from the ovary and other parts of the flower. Example, pineapple. Now, I made a mistake not asking if anyone has a question to ask. So let me open up for just a minute for any question that would be asked. Just a minute. Okay, so there's no question. Let me continue. Okay, again, based on the number of flowers that are formed on the fruit, it's classified under three components. One, you have simple fruits. Two, aggregate fruits. Three, multiple, also called compound or composite fruits. So based on the number of flowers that are formed from the fruit, fruits are classified under simple, aggregate, multiple, compound, or composite fruits. Now, what are these simple fruits? What are these aggregate fruits? What are these multiple fruits? Now, these simple fruits are formed from one flower only. One flower only, either with a single carpel. Example you have in cowpea, sunflower, or many fused carpel. Example tomato, orange. Now, what it means is that it's formed from just a single flower, having one uh, uh, a single carpel. The single carpel, as you all know, that forms the female reproductive part of a flower. That's a single carpel. Or many fused carpels. So the carpels are fused together as one. That is what we call a simple flower, fruit. Sorry. Now, two, the aggregate fruits. They are also formed from only one flower, having many free carpels. So the carpels, that is the female reproductive part on that flower, are many. Example, you have cola, raspberry, berry, blackberry, strawberry, the berries family. They are all under the aggregate fruits. Then the third one, multiple, compound, or composite fruits. Now they are formed from flower, a plant, or they are fruits that are formed from many flowers. So the flowers are many. Or the flower is from an inflorescent flower, or a cluster of flowers, several flowers. Example, the pineapple, the fig fruit. They are all examples of multiple or composite fruits. Now let me inquire. I want each one of you to give me one example of a fruit you know by the using the chat. Use the chat. Send me one example of a fruit you know before you continue. So I'm waiting for one example of a fruit you know. So use the chat button and send me a message. One example of a fruit you know before you continue. No one should mention the fruit that I have here. The fruit I have here is only for me. The fruits are a lot. No one should mention the fruits I have here. So use the chat button and send me one example of a fruit you know. So Michael, Popo, Michael said Popo. Sparky, mango. Ama is also saying mango, right? Okay. Michael again, avocado, pear. Michael Nyakun, guava. Dominic, tomato. Nice. Sandra, watermelon. Okay, Daniel, apple. Ama again, apple. I need two more. Okay. So Michael, strawberry. Then Sparky. You have lychee, which looks as if I've not heard before. Um, Range of fruits that are available to us. Now I'm going to show you the fruit in the form of a flowchart. Then I would speak and talk about how they are, how they look like. If there are images I need to see, I'll show you. Now, there are footnotes that attached to it. So I would be using a footnote, but you'll be observing from the flow chart. After, I'll give you the footnote so that you look through and know what I'm talking about. So these are classifications of simple fruits. Classifications of simple fruits. Now, this simple fruit is further classified under dry fruit and succulent fruit. So the simple fruit is classified under dry and succulent fruit. Now, this dry fruit, they are fruits that they are pericarp, that is the outer covering of the seed, that is a fruit wall. It dries up when the fruit is ripened. So when the fruit is ripe, then the fruit, the pericarp, that is the fruit wall, it dries up. Now with the succulent fruits, their pericarp, that is their fruit wall, the fruit around the fruit, that's what you can see, remains juicy, succulent, and fleshy when the fruit ripens. So when the fruit is ripened, on my kind of tree says adina abrea. When it's ripened, it still looks fleshy, juicy, succulent. Now, under this dry fruit, there are two further classifications where we can classify these dry fruits under dry dehiscent fruits and dry indehiscent fruits. The dry fruits are classified as dry dehiscent fruits and dry indehiscent fruits. Now, what is this dry dehiscent fruit? Now, they are fruits that their pericarp splits open to release seeds when the seed is the fruit is ripened, or when the fruit is ripe. The pericarp splits open to release seeds. But with the dry indehiscent, the pericarp does not split open when the fruit dries up or is ripened. So the difference between dry dehiscent and dry indehiscent is that the dry dehiscent, it splits open when the fruit is ripe or it dries up. But with the dry indehiscent, the fruit does not split open, or the pericarp does not split open to release seeds when it's ripened. Now, under all these, there are further classifications under them. So with the dry, there are 4 other classifications under them, where we can classify 1, legume or pod, 2, capsule, 3, follicle, and 4, schizocarp. So these 4 types of fruits or classifications of fruits are all under the dry dehiscent fruits. Now with the legume okay, I'm not having an image for the legume, so let's continue. So the legume is formed from only one carpel with a thin pericarp. Now the fruit has a locule. Now this locule is the space in the fruit in which seeds are found. So when you take one mango fruit, the whole fruit is one locule. But when you take a fruit like desmodium, it has about more than 3 locules. That is a confinement containing seeds. So on the same plant, on the same fruit, but it looks as if there are divisions among them. Now this locule, if you've seen a flamboyant before, I don't know if you've seen a flamboyant fruit before. It's very hard when it's dried up, very hard and long, very long. Or this cotulera, they are small. They look like they are legumes. When they are dry, when you step on them, they make some crunchy noise. Crow. Those things they split to release seeds. Now inside you see that there are compartments inside where one seed lies. Each seed lies in one compartment. Now that compartment is what we call the locule. Now this same legume, when the fruit is matured, it can split along each end of the fruit. Now this end of the fruit is what we refer to as line of weakness. So this line of weakness exposes the fruit to be able to split open. The line of weakness is also referred to as the suture. So you can have a fruit that splits from 2 lines of suture or one. When it splits from one, it's either on the top or the bottom. But when it splits from all the 2, it splits from the bottom end and the top end. So you have 2 lines of sutures. So as you can see, examples is what you have. Examples of legume or pod, you have cowpea, flamboyant, bean, pride of Barbados, cotulera, as I mentioned earlier, cotulera, then pea. They are all examples of legume. The second one, capsule. Now this capsule, they are formed from many fused carpel, and they split along many sutures to release seeds. They split along many sutures to release seeds. Now this is an example of a capsule. What you have beside the desmodium on your right. Now, like the okra, when they are matured enough, very dry enough, you see that it opens up on its own. It's placed to release the seeds. Now, this Dutchman pipe here is matured, so it breaks open to release seeds. You have seen some before, but you didn't know that this is what we call the Dutchman's pipe. It's also a form of fruit. Inside, you have seeds inside. The seeds are as if they are in the form of a cushion-like structures. Okay. So examples of these capsules, you have balsam, you have the okra, castor oil, canna lily. The next one, follicle. Now, this follicle is formed from one carpel. So the follicle is formed from one carpel and has only one locule. So just one compartment housing the seed. So just only one seed may be released from one seed. Example, cola. Or there's you can have examples of ones that can release many seeds in one compartment. Example, you have the sodom apple. The next dry dehiscent, you have the schizocap. As I mentioned, it's also formed from one carpel. Then it's placed to release just one fruit containing so many locules on it. It's placed to release many seeds. Now this is how the desmodium looks like. Food or monkey biscuit. That's how some people call it, monkey biscuit. Now look at it. You see that you have 1, 2, 3, 4, 5, 5. It looks like 5 compartments housing one seat each. Now that's one compartment is what we call the locule. So one locule, 2, 3, 4, then 5. So 5 locules on the one fruit. Now each contains one seed. So when the fruit is dried up, it splits open to release all the seeds. That is what we call desmodium. Desmodium. Okay. Now let's move to the dry indehiscent fruits. Also, you have further classifications as acne, Sepsilla, Chiopsis, Samara, and Nut. You have examples under them. Now with the acne, the first one, the pericarp dries open but does not split, as I said. So this one, they don't split to release the seeds on their own. Why with this one? Normally, the seeds are normally attached, or they are fastened to the walls of the fruit. So that's how come they don't normally split open on their own to release seeds. So examples of acne, you have sunflower, you have dandelion, you have wheat. So let me show you the acne of a sunflower. So as you can see from over here, this is the fruit of the sunflower. Now you can see the pericarp, what's around it, the coat around it, then the seed inside. This is an acne. Okay. Number 2, Sepsilla. Now this Sepsilla, as we mentioned after fertilization, there are some structures that still persist. They don't wither off, like the calyx. Now this calyx of a tridax plant persists and forms a parachute-like structures called the pappus. Let me show you the image of it so that you know. So this is a tridax fruit. Now the calyx has persisted to form the structure called the pappus. So this pappus here is an extension of the persistent calyx that has formed to form this pappus, and the fruit is found below it. The fruit is found below it. The next one, you have chiopsis. Now this chiopsis is a single seed. Most of the time, this single seed is attached to the dry pericarp, that's the dry fruit wall. Example is what you have, the maize grain. The maize grain. So normally the fruit, the seed is attached to the tester. The seed normally gets itself attached to the tester. Example is the maize grain. So when you look at the maize grain, look at the maize grain here on your left. Now, at the bottom of what you are seeing, the diagram you are seeing here, is where the hilum is, point of attachment of the seed to the fruit wall. Then you have remains of the star on them. So this is just to show you how the fruit looks like. You've all seen some before, but you don't really take notice of them. The next one, Samara. Now the Samara is similar to the acne, but it has a prominent structure that has projected into something like a parachute-like, a wing-like, and a wing-like structure. Let me put it that way. So uh, the calyx there has persisted or has stayed enough to form a wing-like structure. A wing-like structure. Examples of this, you can have maple, tecoma, combretum. Let me see whether I have images of them for you. No, what I had. Okay, so they form kind of wing-like structures, like wings. I'll get to images before the class ends. Okay, then the last dry dehiscent fruit is the nut. Example, nut of the cashew fruit. Now this is the nut that you have. So the head of the cashew fruit is the fruit itself. Then the seed is found just below the cashew fruit. Okay. So these are images that would enable you to understand what is going on. I'll come and explain the coconut aspect later on. Okay, so these are the footnotes, what I just explained about the flow chart. So you have everything here. In dry fruits, it explains. In succulent fruits, explains. Dry dehiscence, legume or pod, capsule, follicle, schizocarp, acne, sepsilla, Cryopsis, Samara. So it explains every or each of the dry fruits. Now let's look at the succulent fruits. The succulent fruits, as I made mention, it's made up of three further classifications. You have one, the palm, two, berry, three, drupe. So under the succulent fruits, you have the palm, berry, and drupe. These form the three classifications under succulent fruits. Now the palm is made up of a three-layered structure. The palm is a three-layered pericarp. Now, when I say a three-layered pericarp, it's made up of epicarp, that is the outer covering. Two, the mesocarp, the inner wall of the fruit. Then the endocarp, what usually moves around or it's around the seed. So the pericarp is made up of these three structures. You have the epicarp, outer layer, mesocarp, middle, then endocarp. That is what you find around the seed. So let's look at the palm. Now the palm has an outer fleshy layer developed from the calyx and the receptacle. So what persists from the calyx and receptacle? Now the core of this palm contains seeds. So look at the apple. The seed is found at the core. That is the middle part of the fruit. Likewise the pear. So these two structures, the seeds are found inside or at the core, the middle of the fruit. But their layers persist from the calyx and the receptacle. Two, the berry. The berry is also a three-layered pericarp, as I made mention. So it's made up of the epicarp, that is the outer covering, then the mesocarp, the inside or inner fruit wall, Then the endocarp, usually found around the seed. Now with this one, that's a berry. Examples, you have tomato, orange. So as you can see on your left, the image on your left is a tomato, then that on your right is an orange. So the endocarp of these berries are fleshy, fused with many seeds. So the seeds are fused around or on the endocarp. Then you have a fleshy mesocarp where you can, in a way, they just around the endocarp. Then you have somehow juicy, succulent, fleshy epicarp. When you see tomato, this tomato is nice, so it has a fleshy epicarp. For example, you have tomato, you have orange, you have pear. Then our last one, you have our drupe. Also a 3-layered pericarp with a fleshy mesocarp. A fleshy mesocarp. The mesocarp is also fibrous. Now it has a stony endocarp which surrounds or moves around the seed. So the seed is found in the middle. Then around the seed is the endocarp. Around the endocarp is the mesocarp. Then the layer where you see and say, oh, this mango is nice, is what is referred to as the epicarp. Now examples we have there is coconut, mango. Now let's look at how the coconut also looks like. I know people have questions about this. Now, when you look at the coconut outside, that is the layer outside that you see is the epicarp. When you use a cutlass and you are trying to break the coconut open, you have a fibrous mesocarp. It looks like fiber, or it's fibrous in nature. Then inside, that is a hard one inside, is the endocarp. Then you have the one you eat and the water as the seed. Now let me make this statement. Coconut on its own can be referred to as a fruit and also can be referred to as a seed. Coconut is referred to as a fruit or a seed. So don't be confused and be like, where is the seed? Where is the seed? I know. The seed is the parts where you eat, that's the white part that you eat, and the water inside. So you can have water seed and fruit seed. They are all inside, and around is the hard endocarp. Then you have your mesocarp, that is fibrous in nature. Then you have your epicarp around them. So this gives you or gives us the structure of the fruit and seeds. Now, I gave assignment the last time. I don't know whether you have done it, but I'll still give it out to you to look out for the differences between fruits and seeds. Very important difference between fruits and seeds. Now, one thing that I also left out is the fact that a fruit has two hilum. Sorry, the fruit has two hilum. That is point of attachment. One attached to the seed and the other attached to the plant itself. So at the point of attachment of the fruit to the plant itself is one scar, then the other is attached to the seed. So you have two scars in a fruit. So take a practical look at this mango, the mango fruit. The point of attachment of the seed to the fruit wall is one scar of the fruit. The other scar is found at the fruit stalk, That is where it's attached to the fruit itself, the plant itself. So fruits have two scars. Seeds have one scar. There's a difference. I hope we are okay. Okay, so in our next lesson, we look at um, dispersal of fruits and seeds. Dispersal of fruits and seeds. And if time would permit, we'll look at germination of seeds. Thank you very much. If there's any question, I'm ready to answer them.